Hey guys, welcome to Pre-Calc lesson 3.9, Locator and upper and lower bound theorems. So, we've got a couple reveals right here. Get your pencils sharpened because we've got some writing to do. First, let's talk about the Locator Theorem. The Locator Theorem. If P of x is divided synthetically by two different values, A and B, so you do that twice, the remainder of A and the remainder of B, so in other words, P of A and P of B, have different signs. So one's positive, one's negative. Then there exists at least one real root between A and B. So I want to pause this, jot this down. I'm going to continue the video and show you a visual of what this means. So here's the Locator Theorem visual. We've got some polynomial. And you're going to do synthetic division. And you do synthetic division, you get P of A. And you get a negative value for your remainder. Basically, remember, the remainder tells you the y value. So that means that function is below the x-axis. Then you do synthetic division again with P of B, and you get a positive remainder. So that tells you that y value is above the x-axis. That means there must be at least one root between them. That's what the Locator Theorem says. You can do synthetic division once, you get a negative remainder. You do synthetic division again, but this time you get a positive remainder. Then between A and B, all right, because here's A, x value, here's B, another x value, there has to be a root between them. And it makes sense, because what you're saying is the function is below for one of those, it's above for the other. It's got to cross at least once between those two values. Okay, let's go back. Now we have an upper bound theorem. All right, the upper bound theorem says if P of x is divided synthetically by a positive value, we'll call C, and all the sums are greater than or equal to 0. So you do your synthetic division, all the sums are positive, all right, or 0, but you get a remainder. Then C is an upper bound, and there are no roots greater than C. So you're not even going to bother checking anything synthetically that's greater than C. Again, you might want to pause the video here, write that all down. So let's get a visual for this upper bound theorem. What this says, again, I have some polynomial, like so, is that I would try to divide C synthetically. And if all of my sums in synthetic division are positive, basically what that tells me is that this is an upper bound. Because if you notice on this piece of the function, it's just going to go up to positive infinity. It'll never turn around and come back down across the x-axis. So that value C, all right, that value C is an upper bound. Because there's no roots greater than it. So I wouldn't even try. Even if there were some other factors of possible roots greater than C, they're not going to work. So I'd only try numbers less than C. One more. Now we have a lower bound theorem. So the lower bound theorem says if P of x is divided synthetically by a negative value, we'll call negative C, and the sums alternate signs, then negative C is a lower bound and there are no roots less than negative C. Pause the video. I'm going to go ahead and show you the visual for that. All right, our lower bound visual. What we're going to have here is I'd have some function like this, and I'd be talking about some value out here. And I try to divide negative c synthetically. And what happens is I get a bunch of alternating signs in my synthetic division. So what that tells me is that negative c is a lower bound. This will never come back and cross the x-axis. It's just going to go on to negative infinity. So I wouldn't bother trying any values less than negative c. I would only try values greater than that. And that's called a lower bound. So now we've got these three theorems. A locator theorem, which helps us pinpoint a root between two values, because one remainder is negative, one remainder is positive, which means one y value is negative, one y value is positive, so the function must cross the x-axis. I have an upper bound theorem, which gives me the maximum, a maximum possibility. You try a positive number, all the sums are positive, it's not a root, don't bother trying anything more than that. And then the lower bound says, I tried a negative possible root, it didn't work, but the signs alternated signs, then it's a lower bound. I wouldn't try anything less than that. All right, so we're going to try all of these theorems and the theorems that we've learned prior to come up with all the roots for these polynomials. Here's our first example. P of x equals 3x cubed minus 13x squared minus 11x plus 5. So my recommendation, always add the coefficients. If they add to 0, then right away you know 1 is a root. So I've got 3 minus 13. That gives me negative 10. Minus 11 is negative 21 plus 5. So 1 is not a root. I'm not going to bother checking that one. Let's list our possible roots. Possible roots, plus or minus all the factors of our constant term, so 1 and 5, divided by all the factors of our leading coefficient, 3. So what can I try? Well, I know it's not going to be 1, so I'm not going to try a positive one, but it could be negative 1. It could be positive or negative 5. And it could be positive or negative 1/3. And it could be positive or negative 5/3. Let's guess negative 3. My coefficients are 3, negative 13, negative 11, and 5. Bring down, multiply, add, multiply, add, multiply, add. So at first glance, like, well, forget that. That doesn't tell me anything. I'm going to go on and try another number. But pay attention. I tried a negative root. My signs alternated. That tells me negative 3 is a lower bound. So I'm not going to bother checking negative 5. I know it won't work. So it does tell me something. Even though synthetic division didn't work to find a root, it told me that I had a lower bound. So I'm not even going to bother checking negative 5. We already knew 1 didn't work, so let's check negative 1. Bring down, multiply, add, multiply, add, multiply, add. Excellent. So I know x equals negative 1 is one of my roots. My depressed polynomial, I start with a cubic, so this is going to be a quadratic, 3x squared minus 16x plus 5. That's your depressed quadratic. 3x squared minus 16x plus 5. Set that equal to 0 to find our other roots. Pretty straightforward. 3x and x. Signs are the same, both negative, and it's got to be 1 and 5. I need a 16, so it's going to be 5 and 1 here. My other two roots, x equals positive 1/3, and x equals positive 5. Again, hopefully that makes sense. It comes from the list. Here's negative 1, check. 1/3, yeah, right here, 1/3. And 5, positive 5. Okay, let's try a few more. Example 2. Same thing. Let's first try adding the coefficients. 2 minus 3 is negative 1. Minus 3 is negative 4. Plus 2. 1 is not going to work. Let's list our possible roots. All right, so could be plus or minus factors of 2, 1, 2, over factors of 2. All right, so not a lot of options here. 1 didn't work. I have no other clues. Let's just try negative 1 again. Coefficients are 2, negative 3, positive 2. Bring down, multiply, add, multiply, add, multiply, add. So again, got lucky, x equals negative 1 works. Here's my depressed quadratic, right? I start with the cubic, depressed at 1 degree. So I have 2x squared minus 5x plus 2. There it is. That's how you get it. You use these numbers right here. 2x squared minus 5x plus 2 equals 0, and I'm going to factor that. 2x and x. It's got to be 2 and 1. Signs are the same, both negative. I'm going to put a 2 here, 1 there. And I get x equals 1/2, and x equals positive 2. Again, should make sense. It's got to come from this, right? Negative 1, 1/2, and positive 2. Now, all of the problems that we've done so far, when we got our depressed quadratic, we've been able to factor. But what happens if you can't factor? Then you have to remember to use the quadratic formula. And we went over that a few days ago. I'm just going to remind you here. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. In certain instances, you could also complete the square if that works, but quadratic formula always works, so I'm just going to keep that for now. All right, so let's keep plugging away here. Let's add my coefficients. 1 minus 9 is negative 8, plus 12 is 4 minus 4. Awesome. So I know x equals 1 is going to work. That's going to be the first one I check. Before I do that, though, I'm going to list all my possible roots. Plus or minus factors of 4, 1, 2, and 4 over factors of, well, just 1. And I know 1's going to work, so let's put that in. Coefficients are 1, negative 9, 12, and negative 4. Bring down, multiply, add, multiply, add, multiply, and add. All right, so that tells me x equals 1 is a root. Here's my depressed quadratic, x squared minus 8x plus 4. And hopefully that factors, but I'm guessing it doesn't because I just talked about the quadratic formula. X squared minus 8x plus 4 equals 0. And you can tell here this is not going to work. X and x, signs are the same, both negative. Factors of 4, 2 and 2. No, 1 and 4. No, that's not going to work. So A is 1, B is negative 8, and C is 4. Let's plug into the quadratic formula. X equals the opposite of B, 8 plus or minus square root B squared, 64 minus 4 times A times C, all over 2 times A, which is 2 times 1. So let's clean this up. 8 plus or minus, that ends up being 64 minus 16. I believe that's 48. All over 2. And 48, if you remember, is 16 and 3. So that's going to be 4 radical 3. 8 plus or minus 4 radical 3 all over 2. And remember what we said about simplifying. You've got to simplify all 3 of these. Same factor in all 3. So divide them all by 2. That's going to be 2. That's going to be 4. My answer is going to be x equals 4 plus or minus 2 square root 3. And that's fine to leave it like that. So here are your 3 roots. 1, 2, 4 plus 2 radical 3. And the third one is 4 minus 2 radical 3. Okay, example 4. First thing you want to check, Add your coefficients. 1 minus 8 is negative 7 minus 8. No, that's not going to work. So I know 1 is not a root. What are our other possible roots? Plus or minus factors of 8. 1, 2, 4, and 8. So I know 1 doesn't work. Let's try negative 1. Negative 1, and I have, now we got to be careful on this one. 1, 0, negative 8, negative 8. All right, and the reason you have to put that 0 in is because remember, these have to go in decreasing order. So this has to be an x cubed, that has to be an x squared, that has to be an x, and that's got to be our constant. So that's why we need a 0 here, because there's no x squared term. Okay, bring down, multiply, add, multiply, add, multiply, add. That's not going to work. Okay, and it doesn't tell me a lot. This one doesn't really tell me much because, okay, I tried a negative number, but my signs did not alternate. Look, those are the same. Those are the same. So it just didn't work. I got to try another one. All right, you don't have to erase it. I can't see the trials. Let's try, I don't know, negative 2. Got 1, 0, negative 8, negative 8. Bring down, multiply, add, multiply, add, multiply. Excellent, that one works. So I got x equals negative 2 is 1 root. My depressed quadratic is going to be x squared minus 2x minus 4. There it is right there. Okay. So let's write that out. X squared minus 2x minus 4 equals 0. Now, if this factors, that would be awesome, but it's not going to. You can tell factors of 4 that subtract to 2. No, it's either 2 and 2, 1 and 4. So you can either get a 0 or a 3. This one is actually a good candidate for completing the square. Why? Because my leading coefficient is 1 and my b term is even. So you could do quadratic formula here. It will work. It always works. But I'm going to complete the square. I want to review that process anyway. So I'm going to move the 4 over. X squared minus 2x equals positive 4. Here's how you complete the square. You've got to take this term. You take half of it. And then you take that and you square it and you add it to both sides. Not just one side, but both sides. All right, so half of that is 1. 1 squared is 1. I add 1 here. I add 1 there. Now, why is that useful? Why does that process work? Because now this can be factored into 2 identical factors. Signs are the same, both negative, so I can write it like this. X minus 1 times x minus 1. But I don't like that. I prefer this because then I can take the square root of it. So I usually skip this middle step, but I want to show you where it comes from. Okay, that's what I'm going to write down first. X minus 1 squared equals 5. Now I take the square root of both sides. That's going to give me x minus 1. And don't forget, this is plus or minus square root 5. And then finally add 1. X equals 1 plus or minus square root 5. There are your other 2 roots. One of them is 1 plus square root 5. The other one is 1 minus square root 5. And then we have this one over here from synthetic division. All right. Double roots. Now, we haven't really seen this with synthetic division yet, but you could have the same number work twice. So, for example, this one right here, again, first thing I would do is add my coefficients. 1 plus 1 is 2, minus 1 is 1, minus 1 is 0. So I know right away that's going to be a root. So let's just try that in synthetic division. 1, I've got 1, 1, negative 1, negative 1. Bring down, multiply, add, multiply, add, multiply, add. Great, so there's 1. Now, here's my depressed poly, x squared plus 2x plus 1, and that I just need to factor. X squared plus 2x plus 1, set that equal to 0. Well, I get x plus 1 times x plus 1 equals 0. So my root is x equals negative 1, but it's a double. You could write x equals negative 1, x equals negative 1, and circle both. You can indicate that it's a double. But notice we still end up with 3 roots. 1, 2, 3. Now, if you were to do this synthetically, and let's say it's a 5th degree or 6th degree, and you get negative 1 to work, don't think that you can't use that again. You could try it again a second time. Maybe it's a double root. Maybe it's a triple root. But it is possible that the same number could work twice in synthetic division. How about imaginary roots? Oh, this one's going to be fun. 5th degree. So again, first thing, I'm going to just add my coefficients. 1 plus 1 is 2, minus 2 is 0, minus 12, minus 8. Nope, I know 1's not going to work. So let's list our possible roots. Plus or minus, factors of 8. 1, 2, 4, 8. My leading coefficient is just 1, so I'm not going to be dividing by anything here. I don't know. Let's try negative 1 first. I know 1 doesn't work. I usually like to stick with the smaller numbers. So I've got 1. Notice we got to be careful, super careful. There's no x to the 4th, so that's got to be a 0. Then I have a 1, negative 2, negative 12, negative 8. Again, just to reinforce this, there's my x to the 5th, there's my x to the 4th, there's my x cubed, x squared, x, and my constant. Bring down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Whew, thankful for that. X equals negative 1. There's one root. Now, here's the thing. This is the first time I think we've seen this in notes. Usually we start with a cubic, and I have a depressed quadratic, and I just factor it, or I use quadratic formula, or I complete the square. But now, I don't have a depressed quadratic anymore. I have a depressed quartic, 4th degree, because I started with a 5th degree, and I depressed it 1 degree. So this is x to the 4th minus 1x cubed plus 2x squared minus 4x minus 8. So now, I can't factor that. I have to do synthetic division again. But I'm not going to go back to the original. Use the depressed. What's going to happen is we're going to narrow it down and narrow it down until we get to a quadratic. So if I have a 5th degree, I do synthetic division once. Now it's a 4th degree. I do synthetic division again. Now it's a cubic. I do synthetic division again until I get to be a quadratic. So I'm still going to use these numbers here to test. I know 1 still is not going to work, so I'm not going to bother with 1. Maybe there's a double root. I don't know. I'm guessing that there is, so I'm going to try negative 1 again. And here's what's kind of nice. Since we've started this, I'm just going to use these numbers right here. You don't have to rewrite it. So I'm going to use negative 1 right here. Bring down, multiply, add, multiply, add, multiply, add, multiply, add. Awesome. So negative 1 is a root a second time. I'm just going to write it down so I don't forget. Now, what do we have? Well, remember, this was a 4th degree, so now I'm down to a cubic. X cubed minus 2x squared plus 4x minus 8. So now that's a cubic. We can try negative 1 again. I'm guessing it's not going to work because I know what the answer is. So let's go with 2. Bring down, multiply, add, multiply, add, multiply, add. Excellent. So I know 2 is another root. Well, now we started with a 5th degree. Then I had a 4th degree. Then a cubic. Now I finally have a quadratic. This is x squared plus 0x plus 4. Or basically x squared plus 4. Let's write that over on the side. X squared plus 4 equals 0. That comes from this. Well, that doesn't factor. All right, so you could do quadratic formula, but this is pretty easy to do square root method. Subtract 4, you get x squared equals -4. Square root it. X equals plus or minus 2i. Now, we don't have to worry about graphing imaginary roots, but I just want to point out we started with a 5th degree, so I'm expecting 5 roots. 1, 2, 3, 4, 5. 2 of them are imaginary, 3 of them are real. And remember what we also said, a 5th degree has at least 1 real root because the tails are opposite, so at some point it must cross the x-axis at least one time. All right, this is the last one, the grand finale. So I have to find all the roots. 1 minus 5 is -4, plus 11 plus 11, so that's going to be not enough to overcome a -78. So 1 is not going to work. Let's list our possible roots. Plus or minus, factors of 78. Holy moly, I'm going to have to do this kind of like this. 1 and 78, 2 and 39, 3 and 26, and then 6 and 13. Wow, a lot of them. So I don't know. I know 1 doesn't work. Let's try -1. That's usually what I do. So let's see. -1. My coefficients are 1, -5, 11, 11, and -78. Bring down, multiply, add, multiply, add, multiply, add, and no, this is not going to work. All right, it's going to be a negative number. So does this tell me something, though? Let's investigate. I tried a negative number. So maybe this could be a lower bound. Do my signs alternate? Plus, minus, minus. Ugh. No, they do not. So it's not a lower bound. This doesn't tell me a whole lot other than -1 is not a root. Okay, don't erase it. Show me that you tried it and it didn't work. How about, let's see, if -1, I don't know, let's try 6. 1, -5, 11, 11, -78. 1 times 6 is 6. Add, that gives me a 1, that gives me a 6, that gives me 17. Wow. 6 times 17, I think that's 102. That gives me 113. 6 times 113 is a huge positive number. I know it's not going to be a root, but I get a positive here. I don't really need to know what it is. Here's what it tells me, though. I tried a positive root. All my sums are positive. That tells me that this is an upper bound. What else do I know? Notice these. This tells me, since I tried -1 synthetically, and I got a negative remainder, I tried +6 synthetically, and I got a positive remainder. There's got to be at least one root between -1 and 6. All right, so I don't know, let's try 3. Got 1, -5, 11, 11, -78. Bring down, multiply, add, multiply, add, multiply. Ooh, what's that, 26? 3 times 26, oh, that's 78. Got it. So I know I have one root, x equals 3. I also now have a depressed polynomial. I'm not going to go back to these. We're done with those. We got one root. I'm going to use these now, okay? And I'm going to apply the same concepts I did up here. I can try any of these numbers. All right, so let me pick another one that might work. How about -2? So now I'm going to try -2 here. on these new coefficients. All right, bring down, multiply, add, multiply, add, multiply, add. Excellent. We got another one. X equals -2. Now, since I started with a 4th degree, let me scroll way up here. I started with a 4th degree. I depressed it once. Got a cubic. I depressed it a second time. Now I'm in a quadratic. This is x squared minus 4x plus 13. So now that's what I need to use to find the remaining roots. X squared minus 4x plus 13 equals 0. This is not going to factor. I know that right away. 1 and 13, there's no way you get a 4. Again, this is a 1. That's even. I'm a big fan of completing the square when you can. So I'm going to go ahead and do that. Move the 13 over. X squared minus 4x equals -13. What I'm going to do next, I'm going to take half of this, and I'm going to square that and add it to both sides. Don't forget to add it to both sides. All right, so half of 4 is 2. 2 squared is 4. Add 4, add 4. Here's how this factors. I don't write this step out, but it's going to be x minus 2 times x minus 2. I'm going to write that as x minus 2 squared. -13 and 4, what's that, -9? Excellent. We get to have imaginary roots here. Square root. X minus 2 equals plus or minus 3i. And the last thing we do is add the 2. All right, so I'm going to add 2 to both sides. I'm just going to write that over here. X equals 2 plus or minus 3i. So that accounts for 2 roots. One of them is 2 plus 3i. One of them is 2 minus 3i. You can write them out separately if you want, but you don't need to. So I've got 2 roots here, 3, 4, and I started with a 4th degree polynomial. So that's a huge problem, but that's kind of what we're gearing up towards, okay? We're going to add graphing to all of this, applying the theorems. So I know it was a really long day. I appreciate you guys hanging in there for the whole video. As usual, please reach out if you have any questions or want to meet via Zoom for office hours. Thanks, guys. We'll see you soon.